Hello and welcome back. Today we are going to talk about histograms. Histograms group data into intervals called bins. Histograms are especially useful when working with larger data sets because they help us see the overall shape of a distribution. Okay, what does that mean? Well, let's take a look. Here we have an example data set. Our data set includes values between 52 and 92 listed in ascending order. Again, they will not always be given to you in ascending order. It is your job to rewrite them in ascending order if not given. It will make your life a whole lot easier if you do. Step one, create bins. So bins are ranges of values that we're going to be looking at. Typically, you want the range to be in an interval of 10. Sometimes you'll see it in different intervals, maybe 100, maybe 1,000, maybe 5. More often than not, it's going to be 10. Our bins are 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. The reason these are our bins is because we're starting at 52, which is in the 50 to 59 range, and we're ending at 92, which is in the 90 to 99 range. All right, step two is count the frequencies. Frequencies are how often they occur. So in the 50 to 59 range, how many values occur in that range? 52, 55, 2. In the 60 to 69 range, 1, 2, 3, 4, 5, 6, 7, missed that again. 1, 2, 3, 4, 5, 6, 7, 7. 70 to 79, 1, 2, 3, 4, 5, 6. 80 to 89, 1, 2, 3, 4. And 90 to 99, 1. Okay, so here are our frequencies. Step three, we're going to draw the histogram. So the histogram is going to look like a bar graph. In the bottom here, for each bar is going to be the bin that we created. Okay, you can see I have them listed here. And then for the height of the bar, it's going to be our frequencies. Now, if we notice here, I put a little, looks like a boop boop at the hospital, a little heart rate monitor. This is called a break. We always include a break if our bar graph does not start at 0. It is letting the reader know that we are skipping to a higher value. To not include one of these would be a form of manipulating data and lying to viewers. We don't want to manipulate anything. We want to be as honest as possible. So we include the break to let people know, hey, we're skipping 0 through 49. Okay. So our frequency for 50 to 59 is 2. Bar graph goes up to 2. For 60 to 69 is 7, goes up to 7. 70 to 79 is 6, goes up to 6. 80 to 89 is 4, goes up to 4. And 90 to 99, we only had one value, goes up to 1. And this is it. This is as simple as it is. This is how we create a histogram. Now, you may see a histogram expressed as a line graph as such. This is also nice for reasons we'll get to in a bit. Sometimes it's nice to view it this way. You will not, more likely than not, you will not see this. However, it might appear up from time to time. This is okay. This is also acceptable. But for any exams you're taking, you're probably going to want it to look like this. I just want to show this because you might see it like this sometimes. All right, let's interpret this thing. The center. So visually, it looks like this area is our center. When we calculate the mean, which is again adding all the values and dividing by the total, we get 71.1. And when we calculate the median, we get 71. That's our middlemost value. So the center of this is the low 70s. The spread is our range, which is the max minus the min. Our maximum value is 92. Our minimum value is 52. 92 minus 52 gives us 40. The range or the spread is 40. Cluster. So here we go. I have it drawn out over here. Makes it easier. Most observations occur between 60 to 79. This is the bulk of it. We have 13 of our, 20 values right here. So we could say this is our cluster. There are no gaps in all of our bins here. They all have values to line up to. No gaps here. Outlier, 92. Is that a possible outlier? When we get to the IQR rule, we'll see for sure. But because there's no gaps, it's safe to say we don't have any outliers for our histogram here. All right, so there's different histogram shapes that we need to be aware of. Okay, we're going to talk about all of them. First is symmetric, when both sides look approximately the same. This is an example of a symmetric one. This one is exactly the same, but you know, like even if like say let's bring this down to 2, bring the maybe this up to 3. Now, we would still say this is symmetric even though it's not perfect because it's close enough. We can it doesn't have to be exact. This is an exact example. But as long as it gives this kind of shape, which we call a bell, if it gives an overall shape of a bell curve, we will call it symmetric. Another example is right skewed. So right skewed, we have here, the tail extends further to the right. This is the biggest mistake I see all the time. A lot of students will say this is left skewed because the higher values to the left. Wrong. It's where it creates a tail shape, which I'll highlight. See, this here is our tail. This is our skew. This thing is skewed to the right. Likewise, left skewed. Here we have it over here. That's what this one looks like. Oops, wrong button. Our tail is here to the left. We would call this one left skewed. Simple enough. Uniform. Bars have roughly equal heights. Again, this is perfectly equal. It could be a little bit off. You know, you could have this one up to here, maybe this one up to here. It's not perfect, but it's close enough. We would call that uniform. And you could visualize it with almost a straight line going across the top. And lastly, bimodal is when we have two distinct peaks appear. Here, there's a peak at 5 and 4. The overall shape of this is going to look something like this. That's a better illustration of peak here and peak here. Bimodal distribution. Cool. So erase this. Okay. So the histogram that we crafted, what would you say the shape of this one is? If you said right skewed, you were correct. You could see we create a tail going to the right side here. It's kind of close to symmetric, but there's too much going on the right and not enough on the left to call it symmetric. So we would say this is a right skewed distribution. Okay. Some advantages to histograms: excellent for making larger data sets, makes patterns easy to identify, and shows overall shape clearly. Disadvantages: original values are not preserved, and that's because of our bins. And different bin widths can create different appearances. We can use that to manipulate data. And, you know, sometimes you'll see in the news data being manipulated to push some type of narrative. We are going to be better than that. We're not going to fall victim to that type of behavior. And common mistakes: confusing histograms with bar graphs. It's presented as a bar graph, but because of our bins, it's not technically a bar graph. Using inconsistent bin widths, they all must be the same. You can't have one bin width of 10 and another of 6, another of 7, another one of 10. They all have to be the same. If you pick 10, 10 is your bin width. Choosing too many or too few bins. And again, the most common one I see, confusing left and right skew. Again, the skew is where the tail is, not where the peak is. All right, here we have a practice problem. Construct a histogram for this data set over here. Again, I have it written for you in ascending order. It will not always be that way. And answer the following questions. I'll give you a moment now to pause, and you can take a look at this. All right. I hope you took a look. Let's check out the answers. So our histogram should look something like this. Our 40 to 4, first off, don't forget the break here. Our lowest value is 40. Our lowest value is 45 and the highest is 90, but our bins are 40 through 49 up to 90 through 99. We have 2 frequency of the first bin, 4 frequency of the second, 5, 5, 3, and 1. And again, 2 40s, 1, 2, 3, 4 50s, 1, 2, 3, 4, 5 60s, 1, 2, 3, 4, 5 70s, 3 80s, and 1 90, as here. Crafted as a bar graph as such. Another thing I want to comment on when creating our graphs, other than the break here, always label your X and Y axis. Your teacher will be happy you did, and it's just common courtesy to always have those labeled. The center, if we calculate the mean, we should get 66.6. And again, the mean is we add all of these values up. There's 20 of them in total. All of them added up divided by 20 is going to give us 66.6. The middlemost number. What's nice about having them listed is you can clearly see these two are the middlemost number, We have an even number of data points here. So you're going to have to take the average of these two. 66 plus 68 divided by 2 is 67. Or you could see that that number is perfectly in between these two here. So our median, 67. Range, our maximum minus our minimum, 90 minus 45 gives us 45. There are no gaps in our bins. We have no apparent outliers. And the shape of this thing, mostly symmetric. It's symmetric enough. Yeah, this is a little higher than this side, but I wouldn't say it's enough to call it left skewed. It still gives this overall shape. So we would say the overall shape is symmetric. All right. That's everything I have for histograms. Thank you for tuning in. As always, this will be posted on YouTube with a link for you to take a look at. Thank you for tuning in, and I will see you next time.